In this example, we're going to calculate 37, take away 14, but we're going to use binary only. Now this is a very popular type of question in the AS computing exam, and when we're going to use binary only, that's important because 37 take away 14 is quite easy to do. But watch this method and see how you get on. I'm going to take my 37 and I'm going to write down the binary equivalent using 8 bits for 37. So I don't need 128, don't need 64, but I will have 32, don't need 16, don't need the 8, I'll use the 4, not the 2, and the 1. So what I've got there is 32, add 4, add 1, and that's 37. Now the trick here is, what I'm going to do is I'm going to go, right, let's take 14, let's work out positive 14. And again, I'm not going to need 128, not going to need 64 or 32 or 16, but I'll use 8. I'm going to use 4 because 8 add 4 is 12. I'm going to use 2, that's 14, but I don't need the 1 at the end, so that's 0. Now the trick here is, if I want minus 14, remember 2's complement, okay? And the way you were doing this was to copy the bits from the right hand side going towards the left, and you copy the bits until you get to the first one, and you copy that one down, and then all the other bits are inverted, so that 1 becomes a 0, that 1 becomes a 0, the 0 becomes a 1, that becomes a 1, that becomes a 1, that becomes a 1. Okay? Now the trick to all this is that 37 add minus 14 is actually the same as 37 plus and a minus make a minus. Yeah, it's the same. So what I'm going to do is I'm going to take my binary for 37, which is 0, 0, 1, 0, 0, 1, 0, 1. Now I'm going to take my negative 14, 1, 1, 1, 1, 0, 0, 1, 0. I've got to try and be nice and neat over this. I've got a 1 and a 0. Add those together, that's a 1. A 0 and a 1 added together makes a 1. A 1 and a 0 added together makes a 1. A 0 and a 0 makes a 0. A 0 and a 1 makes a 1. A 1 and a 1 makes a 0 but a carry 1, so I put the carry underneath like that. A 0 and a 1 is a 1, but a 1 and a 1, because of the carry, is a 0 carry 1. And again, we've got the same thing. We've got a 0, 1 and a 1, which is going to be a 0 carry 1. Now I've got my 8 bits here, so that, I'm afraid, isn't going to count to much. We'll lose that. And then let's see what we've got here in binary bits. We've got a 1, we've got a 2, we've got a 4 using the weightings. We don't have an 8, but we have a 16. Let's add those together, see what we get. 16, 4 is 20, 22, 22 add 1 equals 23. Well, hey presto. 37 take away 14 equal 23. So this mathematics proves that the calculation can be done in pure binary only, and the key thing is, make sure with questions like this you show all you're working out, and if you do that, there's some straightforward marks to be had in the examination. So go away and study this and make sure you can do it.